Hello, CHistrue here. Today I want to discuss the idea of an infinite universe. Now, when I was growing up, this is going to really show my age, I grew up in the universe that cosmologists believed in. And that was the idea that you could liken our universe to the surface of a sphere, and that sphere was being expanded since the time of the Big Bang. Only we didn't live in a two-dimensional surface of a sphere. We lived in a three-dimensional surface of, let's say, a hypersphere, or something that would have greater dimensions than our ordinary three dimensions. Okay. Now, that could be structured in different ways. When string theorists got in there, it was any number of given dimensions depending on the particular variant of string theory that we're referring to. The point is, though, that the universe was seen as being finite but unbounded until very, very recently, when the idea of a flat universe seems to have made a comeback. Now, the flat universe would be the old Euclidean universe, the old universe of before Einstein, when there were non-Euclidean systems of geometry. They were known to mathematicians, but they were not accessed by physicists or by philosophers. Once Euclid's fifth postulate was proven to be independent, you could then come up with systems of geometry that did not rely upon Euclid's fifth postulate. And eventually, that particular system of thought, non-Euclidean geometry, was adopted for large-scale distances. And we had the idea that if you shot a spaceship and then the spaceship just kept going, it would eventually return the other way. A nice, kind of comfortable universe to live in. Finite, huge, but ultimately one that was safe, cozy, if you will. Lately, physicists have been moving, they haven't repudiated relativity, but they've been moving towards the idea of a flat universe, or a universe where, yes, there was a Big Bang, but that Big Bang was an immediate transformation from a singularity to an infinite universe. And then within that infinite universe, you'd have the expansion of stars, but that the universe remains infinite all the way through. And if you think about it, that makes as much sense as a transformation from a singularity to a finite universe, if you really think about the nature of infinity and what it is. In other words, the infinity of rational numbers, let's say between 0 and 1, would correspond to the infinity of rational numbers that would exist on the real number line. So that's not so difficult to understand, but I think that it does raise some questions, and I'd like to go into them. It wasn't too long before Einstein discovered relativity that mathematician George Cantor also made a set of discoveries about the nature of infinity. If you assume infinity exists, okay, if you postulate that there is such a thing as infinity, and you know if infinity does not exist, then what's the end of the number line? Where does it end? I mean, it seems like those who deny the existence of infinity, if they're finitists, they should at least ask themselves, all right, if the infinity does not exist, then isn't the burden of proof on them to declare where arithmetic would end? But I'm not going to go down that road right now. I'm just going to stick to cosmology now for a time. But I have to detour a little bit, and that's because it's relevant. Cantor began to explore infinity and discovered that, in fact, not all infinities are the same. That in mathematics, you have different levels of what would eventually be called the transfinite. You have the Aleph naught, which would be the infinity of the countable numbers, natural numbers, rational numbers. Then you have the infinity of the reals, which would be the countable numbers and the rational numbers, but also the irrational numbers, okay, the transcendental numbers. And that these are two different levels of infinity. And then, of course, there was the question of, do we have gradations of infinity between those two? Those who believe in the continuum hypothesis would say no. Those who disbelieve in the continuum hypothesis would say yes, or probably. Okay. So if the universe is infinite, well, let me make my point. Once Einstein came along, not too long after Cantor, they didn't have to ask very many questions about what an infinite universe would mean, because we didn't have an infinite universe anymore. But if we're going to go back to having an infinite universe, then we have to ask the questions that were delayed. Namely, what infinity are we referring to? If space and time is continuous, are we then referring to the continuum? If space and time is discrete, are we then referring to all if not? What about the levels of infinity that some, possibly most mathematicians would suggest would lie between all if not and the continuum? Or if the continuum hypothesis is true, then would there be some universes that would be infinite in a discrete sense, but other universes infinite in a continuous sense? If we have an infinite number of universes, would that number of universes correspond to the countable infinity, or, which would seem logical to me, but some might argue that they might correspond to a higher level of infinity than that. And it would also ask the question of what the Big Bang ultimately was, because as I understand it, the quantum physicists, now I may be really simplifying things, but quantum physicists have tried to get away from this idea of a singularity, that many scientists are uncomfortable with the actual existence of a singularity except in a mathematical sense. Okay, so through uncertainty, the idea of a singularity becomes blunted. And so in essence, that would fit with a philosophy of finitism, a finite universe. There's no transformation from that would be a kind of quantum leap between levels of infinity. And yet, if we were to presuppose an infinite universe, we would have to ask a question. Did it start from a singularity? Did it start from another infinite universe that would correspond to known matter being closer together, but still infinite? If we do propose the idea of a singularity leading to an infinite universe, how did that happen? Now, according to Cantor's own research would be the wrong term, but according to his own speculations and discoveries, the idea of a singularity leading to a finite universe versus a singularity leading to an infinite universe, that's not so difficult to understand, because if that finite universe is continuous and not discrete, then it's actually the same infinity. If you were to imagine an infinite number of points, it'd be the same infinity as in an infinite number of universes. So that's not so difficult to understand, but the point is the question needs to be addressed. What do we mean when we say we live in an infinite universe, if indeed we do? What it means is that you're going to have to call the philosophers. That's right. Dial 911 and you get the, and it's an emergency, dial 911 and you get the philosophers. Okay? I don't have any answer. I hope I haven't wasted your time. I have no real definite conclusion here. What I would say, though, is until that issue is addressed, what does it mean to say we live in an infinite universe? It might be best to say that we live in a space-time continuum that we have not been able to establish its bounds. In other words, what is the size of the universe? Now we have the 13.7 light-year window radius of the known universe, but I mean, what is the ultimate size of the universe? It would be best maybe to state that it is an unknown, that it has not, that the curvature of the universe might be infinite, or it might be that it's finite and yet so large that there is no plausible way of measuring it. That might be a better answer than to say that the universe is infinite, if indeed that infinity is as yet undefined. The same I would say for parallel universes. It might be, if indeed they are discovered, let's say that dark matter is discovered to be the matter in some other brain, what we would call a parallel universe influencing us, and according to string theory that would be, according to M theorists, that would be possible. But are they infinite? Do we have infinitely many? I mean, it's an interesting question, because if we don't, then where's the end of the universe? I mean, the same argument for mathematical infinity could correspond to the infinity of the universe. But on the other hand, if we can't define what the infinity of the universe would mean, it might be best to leave it an open question. Well, this is CHistrue, signing off.